Now that we've learned what the cross sections are, we're going to combine that with revolving a shape around an axis and then finding a cross section. So here we see that we've got a triangle, 2 points on the y-axis and then 1 point over on the right, just off of the x-axis. And we want to find the area of the cross section made at the line x equals 2 if the triangle that we see there is revolved around the line y equals 0, or in other words, the x-axis. So the first thing we want to do with this is we want to revolve this around the x-axis to create a three-dimensional solid. Now, that might not be easy to visualize, so I'm going to use one of the resources that I shared with you guys, and we're going to revolve this triangle that we had around the x-axis. So I can select what coordinates I want for the triangle. So I've input those coordinates at 0, 1, 6, 1, and 0, 4, so that they would match our triangle that we had here in the problem. And I wanted to revolve around the line x or y equals 0. So I want to make sure that I've got a crossed y equals, and then this 0 here is the 0 that I'm looking for. Then I'm going to select revolve. When I do that, it's going to spin that around three-dimensionally so that I can see that I've got a cone, but it's got a hole in the middle. So it kind of looks like a volcano tipped over on its side. So if I come back here, if I wanted to sketch that out on my drawing, I know that since I'm revolving around this line of y equals 0, I need to be equal distant on both sides from that line for my cross section. So I've got this line that would match the horizontal. That triangle has a side of 3, so I'm going to go down 3 on this side, and then I can connect those up to form that triangle. But I wanted to take a cross section at the line x equals 2. So if I look at doing a cross section right here, I'm slicing that three-dimensional object on the line x equals 2. Well, if we go back to our solid here, when we looked at it from the cross-section view, we had that outer circle, but then we have an inner circle because we weren't touching that rotational axis. So if I look at that cross-section, I've got an outer circle to look something like that, but then I've got that cutout in the center because of this gap in between the two solid pieces. Now, if I want to find the area of that, that's just two circles being subtracted. So I need to know how far is it for the radius of that inner circle, and how far is it for the radius of the outer circle. Well, that inner circle is just going to be the gap that we have between the two shapes. So if I look at that distance between where I rotated and where the object is, that distance is going to be a distance of 1 unit. Or if I look at the distance between where it hits the triangle and where I rotated that solid around, that distance right there is going to be a distance of 3. Because I have that one open spot between the shape and the axis, but then I also have 2 more units inside the triangle before I hit the slant on the triangle. So that distance on the outside is going to be a distance of 3. So then if I want to find the area, the large circle versus the small circle, I'm going to say pi times the radius squared, so pi times 3 squared for the outer circle, so that's going to give me 9 pi for the area of that one. The smaller circle, I've got pi times the radius of 1 squared, so I end up with just 1 pi. So if I want to find the circle with the circle cut out, I'm going to take 9 pi, subtract the 1 pi from the circle in the center, and I end up with 8 pi units squared as the area of that cross section. So the first thing that we did on this is we revolved it around three-dimensionally to get that volcano looking solid, the cone with the center cut out. But then we took a slice where x is equal to 2 and saw that we had a circle within a circle for that cross section, the two-dimensional shape. We found the area of both of those circles, subtracted them, and got 8 pi as the area of the cross section.